So till now we have not discussed much of the physics, but let's start with one. So when we all are familiar that this is how we define momentum in classical mechanics. Very initial level of physics. This is mass, this is velocity. But in quantum mechanics, we all might have seen that there is something like this. But how to derive it? So this is what we are doing. So till now what we have been observing is that eigenvalues of the observables are discrete. But we can move to continuous eigenvalues now. So like position, there can be many other continuous eigenvalues. So let's start with that. So let's say that we have an eigenvalue equation where this is an operator. This is peak alpha called C, which is uppercase form. This this is a operator which is operating on a state and is giving me eigenvalues which are continuous. So according to that, few of the things will now be changing. First one is this. This will now change to this is Dirac delta. Then the completeness relation. Instead of this summation, we will have now a summation, we are moving to the integral. Because of that, the state which was previously expressible in terms of this kind of form going to change. This means summation of all complex coefficients. This will be large. Overlap of two arbitrary states. This is second state of operator P. It will give me some plus A double prime A prime product by delta. This will now change to without delta. It's not good to use this notation because we have defined a new operator which will be having continuous this is an operator which we have defined recently will operate on this any eigenvalue which is continuous eigenvalue and then I will get the result. Okay, so one of the variables or observables which can have continuous eigenvalues is position operator or position observable. So let's take a look at the writing gates and what will happen about measurement. So consider a position or coordinate operator and 1D. Then this is X position operator. X. This is some value of position, let's say like 1 centimeter, 1 nanometer, 1 angstrom. Not like this will be classical, but any value which says that this is a distance or some coordinate. So there is something that we are postulating here that these position eigenfeeds they form a complete set. Then an arbitrary state, say alpha. I want to expand this using this x prime. We will just visit it. It will look something like this. And this is from minus infinity plus infinity. So this is some arbitrary state represented in this position basis. Now suppose we have a detector that clicks when particle is at some position in p prime or x prime. So when it clicks, we say that alpha jumps to the state x prime. So some state alpha is there. So we say that when it is detected at some position, or detector jumps to the eigenstate of some observable. Let's say this x is x prime, something like this. But we know that in reality, these detectors have some limitations. So what will happen? It will have certain range. Say this prime minus. There will be some plus or minus range. Error always in some instrument will have limitations. So what will change now from this infinite positions to we go towards only this region, others we are neglecting. Then what happens is this. From infinity we go towards only say we have changed this. And let's say assume that just inner product does not change a lot in this inner product. In this particular range, not for the infinite range, but for this particular range, this inner product does not change a lot. Then probability let this interface will click. Is this no? I'm saying this in this range is not changing a lot. So I can bring this outside here and this complex conjugate of each other. So I can take this as this will give me this function. This will give me right. So what we have assumed is that this is not changing on. So this is nothing same. Similarly for three-dimensional space. Also, what we are doing is this. We are able to measure the simultaneous. We are able to measure this simultaneous components of a position identity. So these operators are measuring the components, specific components of the XYZ coordinate, and we are able to do this simultaneously. So that means that we are assuming something here, that no measurement is disturbing any of the components. This means that position operators commute